Hi guys, in this video let's discuss how do we set the threshold value properly for the binary classification problem that we are working on. So for binary classification we use algorithms like logistic regression, which will output a probability between 0 to 1, right? So the probability should be mapped to classes 0 and 1 so that we get a binary output, right? So for that we use decision rule, where if the probability that for a given x the output is positive, is above some threshold, then we set output to be 1, otherwise we set the output to be 0. So let's take a real world example to understand how do we set the threshold. So here I have created a illustration showing diabetes detection test, and the green circles on this line represent the negative values and the red circles represent the actual positives, and the line represents probability from 0 to 1, and each data point falls on this line where the probability of the logistic regression output for this particular sample represents. So we can see there is some overlap between the green and red circles. So in real world this is always the case, that it is very difficult to have a clear distinctive boundary between negatives and positives. There will always be an overlap. So that is the reason why we need to identify what the suitable threshold would be so that the model performance would be better. So before understanding how we set the threshold, let us revisit some of the concepts in binary classification. So we know the confusion matrix. So confusion matrix is drawn between the actual values for the samples and the predicted values predicted by the model, in this case logistic regression. So we have positive, actual positive, that means whether the sample is actually positive or not, and what the model have predicted, whether the model have predicted positive or not for that particular sample. If the actual sample is diabetic positive and also the model has predicted positive, then in that case we can say like the model, whatever the model has predicted is true positive, and all the samples that falls in this quadrant are actually positives and the model also has predicted to be positive. And in this quadrant the model is predicting the sample to be positive, but the actual value is negative for that sample. So that means the sample is negative but the model is predicting positive. So in that case it would be false positive. Similarly, false negative would mean the model is predicting negative for an actual positive sample, and for true negative the model has predicted negative, it's also a actually negative sample. So let us visit some of the derivations that we can derive from this confusion matrix. So we are telling number of true positives plus false negative is equal to number of positive samples, number of true positives plus number of false negatives, right? So true positive means actually it is positive and the model has predicted positive. False negative means we are telling negative but it is actually positive. So all the values that fall in this quadrant, right, all the values that fall in this quadrant is equal to number of positive samples, right? That's what the confusion matrix is also telling. So out of all the values we have actual positive values and actual negative. So this true positive plus false negative would fall under actual positive samples. Similarly, true negative plus false positive, sum of these two would be equal to total number of negative samples, right? And also, since this sum is constant, if the model has predicted lot of true positives, that is if the true positive count increases, then automatically false negatives would drop, because sum of these two is constant, right? Actual number of positives in our data, in our training data. So if we have some 100 samples in our training data, there would be some 60 positives and 40 negatives, right? So this 60 is fixed. So in this 60, the model, if it predicts a lot of true positives, then obviously false negatives would drop. Similarly, total number of negatives is 40. So this value is constant. True negative plus false positive is constant. Similarly, if the model has correctly predicted a lot of true negatives, then automatically the false positives would drop. So with this knowledge in mind, let us try to understand how we can fix the threshold when working with binary classification problems when using algorithms like logistic regression. So these are the popular techniques that we use for fixing the threshold. So the first one is using ROC curve. ROC means receiver operating characteristic curve, and we can use it to set the threshold. So we can also use precision recall curve. Based on the precision and recall values, we can decide what the optimal threshold should be. And these are related that based on the precision and recall we calculate, and for that particular problem which we are solving, we can fix the threshold. Let's continue and understand how to use each of these techniques. So first let's understand ROC curve. ROC stands for receiver operating characteristic curve. So it's a graph that we plot between true positive rate and false positive rate. So what is this true positive rate and false positive rate? So true positive rate is nothing but number of true positives the model has predicted over number of true positives and false negatives that the model has predicted. So we have discussed in the confusion matrix, right? What is true positive, false positive, true negative and false negative. So now we are telling true positive rate is nothing but true positive by true positive plus false negative. So we have already seen true positive plus false negative is nothing but, we have already seen true positive plus false negative, right? That is nothing but number of all the positive samples that are present in our data. So this ratio is nothing but out of all the actual positive samples, how many samples the model is able to correctly predict. So that is the true positive rate. And false positive rate is nothing but false positives by false positive plus true negative. So false positive plus true negative is again here. So that is nothing but number of negative samples in our data, right? So this false positive rate is nothing but number of actually negative samples that the model has predicted to be positive. So in our data we have some negative samples, but our model is predicting them to be positive. So that ratio is nothing but the false positive rate. And these values will change based on the threshold, right? So in this case, if we see, so if I set my threshold to be somewhere here, if the probability is above this particular value, let's say some 0.42, then all the values that are on the right side of this would be positive and all the values on the left side of this would be negative. But we can see there are some negative samples that are on the positive side, so that means we are predicting these negative samples to be positive. So these would be false positives, right? Here we have 3 false positives. Similarly, we have 2 false negatives also here. So we are telling these 2 red samples to be negative, but they are actually positive. So by moving this threshold to the right or left, we need to choose the threshold such that we get least false positives and false negatives. Okay, so for that we are using this ROC curve, and we are plotting what is the true positive rate and false positive rate for each of the threshold. So here I have plotted, so these values are the thresholds. When threshold is set to 1, 0.8, 0.7, how the true positive rate and false positive rate are changing. So let's take an example. If the threshold is 0.4, what would be the true positive rate? So true positive rate is nothing but number of samples predicted correctly positive. So if I set my threshold as 0.4, that is this, how many samples we have predicted to be positive? 1, 2, 3, 4, 5, 6, 7, 8, right? So we have predicted 8 samples to be positive correctly out of all the positive samples. So in this example, for convenience, I have taken number of positive samples to be 10 and number of negative samples to be 10. So this calculation, what would be the true positive rate? So it would be 8 over 10, that would be 0.8. And what would be the false positive rate? False positive rate is nothing but number of negative samples predicted as positive. So that means we set the threshold to 0.4, right? This one. Don't get confused with this line. This line I have just taken for an example while explaining before. So this is the threshold line that we are discussing now. So above 0.4 threshold, how many samples are there which we predicted to be positive but are actually negative? How many are there? One, we have to count green circles here. 1, 2, 3, 4. So it would be 4. There are 4 negative samples that we predicted as positive, and number of samples that are actually negative are 10. So it is 0.4. As we can see, this is the value that we got. For threshold 0.4, we are getting true positive rate as 0.8 and false positive rate as 0.4. So ideally what we want the model to predict or identify all the positives. All the actual positives should be predicted by the model as positives. That means we want maximum true positive rate. So if we see here, as we keep increasing the threshold, initially when the threshold is set to 1, that means at the extreme right, the true positive rate is 0 and false positive rate is also 0. But as the threshold is like moving from 1 to 0.8, 0.7, 0.6, till this point true positive rate is increasing. So you can see till 0.6, till this value there are no negatives. So as the threshold is moving from here to here in this direction, we are covering a lot of positives, but there are no negatives in this. So that's why true positive rate is increasing and false positive rate is remained at 0. But the moment we start changing the threshold, moving it to the left, then we will be adding some false positive to our prediction. So in that case, the false positive rate would keep rising. If you want to increase the true positive rate to maximum, then in that case we need to sacrifice for some false positives. So we would be getting some false positives as well. So the ideal case is we want to maximize the true positive rate, but at the same time we don't want a lot of false positives also. So it's a trade-off. So generally we prefer, we have a rule like how to calculate the threshold. The threshold that maximizes the true positive rate minus false positive rate. That means threshold should increase the number of true positives and also reduce the number of false positives. That is one way to decide the threshold using receiver operator characteristic curve. Let's discuss about the other two methods in the next video.